So today we are going to cover the most important topic of the modern control system, that is the controllability, right? So the concept of controllability we will discuss today. So controllability. So let's say we have a system. Consider a system x dot is equals to ax plus b and y is equals to cx plus d, right? Where x, what is x? X is a, please let me confirm, x is a
It's a
state
state
vector.
variable vector.
A state vector, let's say this is the n dimensional, right? N dimensional. However, u is a, please what is this? U is a input.
Input.
U is a input. This is stuck. U is a control input, m dimensional, right? And finally y. Y is your, please, output vector, yes? Or let's say it is the p dimensional. P dimensional. Okay. So the matrix the dimension of the matrix or the order of the matrix becomes n by n. The B matrix is of the n cross m. C, anyone can tell me? C dependent on, please tell me. P cross क्या हो जाएगा? N, है
P
ना?
cross N.
And what is the D? For the D matrix, please let P cross
P cross M.
M. Okay, so these are the order of the matrix. Okay, and the okay, एक और command, there is a one command in the MATLAB. You can convert the state space. Let's say in the MATLAB you have to define A matrix, B matrix, C matrix, and D matrix, right? And after that you can represent the uh, x dot is equals to x plus u plus y is equals to x equals to, right? So you can convert SS, the state space, to transfer function, right? Transfer function SS to 2f, right? So how you can find in manually, how you can determine the transfer function from the state space? What the formula? C
C
into
into SI minus C
Si minus
inverse
A
into
plus
plus D
into
plus D
B plus
plus
D. This is the standard formula for the use for this. Now I'm coming to the, you are aware of this concept. Okay, now see the controllable. The formal definition of, I'm just taking out the formal definition. What is the formal definition written in the book? So the controllability is formal definition of this system is a system is said to be controllable at time t naught if it is possible, by means any unconstrained control vector u, or you can say control vector to transfer the system from any initial state, any initial state x of, let's say, t naught, to any other state in a finite time, finite interval of time, or you can say finite time. So आपको समझ में आया बात कि क्या क्या लिखा है यहाँ पे? आई एम ट्राइंग टू clarify this statement. What is written? What is the mean of this statement? A system is said to be controllable. A system is said to, ये controllable कब कहलाएगा? किसी भी टाइम t नॉट में सिस्टम कंट्रोलेबल कब कहलाएगा? जब कोई कंट्रोल वेक्टर, व्हेन एनी कंट्रोल वेक्टर, राइट, यू, कंट्रोल वेक्टर को किससे रिप्रेजेंट करते हैं बेटा? यू से. एनी अनकंस्टेंट कंट्रोल वेक्टर यू, और व्हाई इट इज अनकंस्टेंट? अनकंस्टेंट मींस ये ड्राइव करेगा. कंट्रोल वेक्टर जो यू है, यू इज ड्राइविंग फोर्स and there's no influence. You is a free, right? You can drive the state of any state of the system. Let's say the system is initially at xt naught, ठीक है ना? कोई सिस्टम हमारा xt naught पर है, यू उसको ड्राइव करके उसको कहाँ ले जाए? किसी भी स्टेट पे, लेट से xt पे, एनी अदर स्टेट xt पे, इन दैट फाइनाइट टी नॉट माइनस टी टाइम पे, उसको फाइनाइट टाइम पे वो कहाँ लेकर जाए? वन स्टेट टू अनदर स्टेट. इज इट क्लियर? थोड़ा वो समझ में आया कि नहीं आया? और उसको कौन लेकर जाएगा? यू.
Input.
नाउ इट इज, आप इसको देखते हैं जरा, हम इसको थोड़ा सा ग्राफिकल फॉर्म में आई विल ट्राई टू अंडरस्टैंड. लेट्स से वी हैव द टू स्टेट x1t and x2t. x1t and x2t. I will take the 10 as the last. Okay. So let's say we have the initial state here. Let's say we have one state initially defined at this place, initial state, right? And we want to drive our, let's say we have a u1. u1 is the, the control vector, control input. In time t, if this initial, state if this state is maybe shifted from this point to this point by the control input u1 in time t, okay, so then the system, this initial state may be shifted, maybe drive to the here, maybe drive to the here, maybe drive to here, okay, any, right, for the, let's say u2t, ut, this is the time frame, right, and the control input. So if you are able to shift or drive your one state to another state by the control input u in time frame t, then your system may be set to as, maybe system set be as a controllable. Okay. तो अब समझ में आया थोड़ी बात कि नहीं आया? यस और नो? यहां तक कुछ क्लियर है? प्लीज लेट मी कंफर्म. Am I audible?
Yes, sir. Clear.
Okay. The system, next line, the system may be partially. What do you understand? May be partially. May be partially controllable. इसका क्या मतलब? What is controllable? Partially controllable है कोई system. What do you mean? Let's say we have x is equals to, x1, x2, x3. There are n number of state existing in this x, right? And let's say half of the x1 up to the xn by 2 state are controllable. However, x I plus 1 up to the xn, these are the numbers, this is the uncontrollable. However, these are the controllable state. Maybe such system maybe exist. Okay, so ये क्या कब होगा? What is the condition where the system may become the partially controllable? Anyone can tell me? Anyone can tell me? You have understand the definition of stabilization, stabilizable. तो stability के लिए, stable होने के लिए क्या सिस्टम होना चाहिए? Please tell me what is the condition for the stability? Please.
What is bounded input के लिए bounded output.
Bounded input, bounded output, and for the state space equation, the eigen value should be in the
No. Left half of this.
negative. Yes or no? Eigen value.
The negative real part.
Yes, negative real part. Yes. So you can say it means If the eigenvalue is negative, or the real part of the eigenvalue is negative, you can say that the system is stable. Let's say some of the eigenvalue are existing in the left hand side and some of the value are right now, let's say existing in the right hand side. Then you can say that some of the poles are stable, however some of the states are unstable. Yes or no? So
Yes.
for such type of the system, you can make, your duty is to make the whatever the pole lying in the right hand side to place this pole in the left hand side. Then your system may become the system stable. Yes or no? So for, you can say, the for partially controllable system, if the uncontrollable modes are stable and other modes are controllable, you can say, then the system is said to be stabilizable, right? स्टेबलाइजेबल. ऐसा सिस्टम क्या है, स्टेबलाइजेबल सिस्टम भी कहलाता है, राइट? अब मैं फिर से एक बार इसको दूसरे एंगल से, वी आर ट्राइंग टू सी द कंट्रोलेबिलिटी बाय द डिफरेंट एंगल. ओके, लेट अस assume here, you know that what is the solution of the state space equation? We have already evaluated xt equals to e to the power at x naught plus 0 to t. Anyone can tell me e to the power a t minus tau
Tau.
b
B
u
U
tau
of tau.
No.
theta,
Okay.
right? And the most important, one of the tests that is very popular for testing the controllability of the system. Anyone can tell me the name of that controllable criteria test? Kalman.
Kalman's test.
Yes,
Kalman.
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 Kalman test. But we will come on that topic also, right? So फिर से थोड़ा सा हम लोग इसको समझने की कोशिश करते हैं. Let's say we have a system x dot ax. ध्यान समझिएगा. We will try to see the controllability in another angle, same, by the for the better clarity. X dot is equals to, हमने let's say consist किया एक ax system है, and the system is pure linear system equation, right? So we can x dot is equals to x d by dt of x, right, is equals to some value of ax. यही तो है, yes or no? So this is the, ये है क्या, it is the, अगर मैं कहूं कि d by dt is equals to kd into d, क्या होता है formula for the, I forgot it, the PID. Okay, so what is this actually? ये differentiation value, anticipating your future, anticipating the behavior, you can say the anticipate the behavior of the system, right? Or you can say that it can predict the future state of the system. Yes or no? That depends on the eigenvalue. Okay. अब x dot एज इक्वल्स टू ax में क्या नहीं है, वो टर्म है b. It means control input is absent. Control input is absent. In the absence of this control input, whatever the system is, either controllable or uncontrollable, we don't know. But we can't drive, we can't change the behavior, right? Because we don't have the control input. Let's say the system, and such type of system may be the stable and maybe the unstable. but you can't change. You can't change the behavior. Let's say we have the second case, x dot is equals to ax plus bu. x dot is equals to ax plus bu. इसमें क्या होगा बेटा? Anyone can tell me? This bu, this bu can manipulate this control input, you can say. In control input, you can manipulate the system. Yes or no? Yes or no? Because अब कैसे होगा इसको जरा देखिए. Let's say हम स्पेस डिफाइन करते हैं जिससे आपको मैथमेटिक्स समझने में आसानी हो. X is a member of real time of this, है ना, and U and A, okay, so that this can be defined in the this space. Right. Okay. So देखिए, let's say we have a system and the system is defined as x dot is equals to ax plus bu, and the whatever the y, what is the y? Anyone can tell me what is the y? In the state space equation, we write y is equals to generally x. Yes or no? Yes.
Yes.
Y equal to x. यहाँ पर हमने जनरली इसको स्टेट को तो मेजर कर रहे हैं. We are just measuring the state. Okay. And for driving the function, for driving this system ax, right, what we are going to take, हमने एक ना u को डिफाइंड किया है, दैट इज द माइनस ऑफ kx. कुछ इस तरीके से. इसका क्या मतलब है? हमने एक कंट्रोलर डिजाइन किया है. ध्यान समझिए, ये u है. एक हमने ड्राइविंग सीट पे हमने एक कंट्रोल यूनिट को बैठा रखा है, कंट्रोल सिग्नल को बैठा रखा है. ये क्या कर रहा है और एक कंट्रोल सिग्नल कैसे काम कर रहा है? कंट्रोल सिग्नल काम कर रहा है, इसके हमने फिजिकली हमने एक सेंसर लगा के मेजर किया कि इसका स्टेट अभी कहां पर है, आइगन वैल्यू कहां एग्जिस्ट कर रहा है और हमें उसको कहां पर लेकर जाना है. उसके लिए हमने एक सेंसर से फीडबैक लगाया और फीडबैक हमारा बता रहा है क्या कि सर अगर आप u is equals to minus of kx if you will take, then you can drive, you can steer your state or system anywhere as per the desire, as per your u, as per the value of u. Is it clear? So what we are going to do, we are just designing a controller, you can say, such that u as a function of what? X state. And what it will do? It will just optimal for the linear system. ये optimal control करेगा उसको. Yes or no? Or you can say in another way that u is equals to minus of kx will shift the system towards the stability. समझ में आ रहा बात में? Yes or no? Yes or no?
Yes, sir.
So this u is equals to minus of kx. अब देखिए, it is the u is the proportionally, this x is changing proportionally as u changing. So it is the proportionally modification is going to done, modifies, right, the system. Proportionally modifies the system. Right. Now let's see. तो u is equals to हमने क्या लिखा? We have written ax plus bu, and where u is equals to of minus kx. You can put here, you can write now x is equals to ax minus of kx. That means a minus bk into x, right? So your dynamic has been changed. X dot is equals to a minus bk into x, or इनिशियली क्या था, x dot is equals to x plus bu. So your dynamics, your total dynamics has been changed. Yes or no? It means you can steer or you can drive your eigenvalue as by choosing the value of k as per your desire. Yes or no? So eigenvalue may be placed anywhere, anywhere in R plane. Yes or no? In a space, in this space, by supplying sensor based feedback. Okay, by changing, you can say by also by changing or by choosing the appropriate value of what, k. Yes or no? Yes or no? So what is the concept? Ultimately the concept is we can shift anywhere, we can shift anywhere the eigenvalue, यही जुगाड़ है, यही concept है. समझ में आ रहा? So now the another formal definition of the controllability we may define it as like this: the system is controllable if for any chosen value of control signal or input u is equals to minus of kx. By choosing the u is equals to minus kx, the system is controllable. क्या करेगा ये u is equals to minus kx? Please tell me. What will do? Huh? Place the eigen. Please tell me. Please, I'm just helping
Negative
you.
plane में.
Place the eigenvalue
Left.
a minus bk. Yes or no? Of the system. Not in the left. Anywhere. है ना? That is depends on the u equals to minus kx. आप कहाँ ले जाना चाहते हैं? Anywhere by good choice of value k. Okay, is it clear? Yes or no? If not clear, you can write the controllability in another term also. The system is controllable, in other words or other mean by right manipulation of u. By right manipulation of u, understand, u को करेक्टली चेंज करके, मैनिपुलेट करके, the state of the system can be, please tell me, please help me in order to write, the state of the system can be steered or shifted, yes or no, anywhere in R space as per the requirement, जैसा हम चाहते हैं, as per the requirement, right? What do you mean anywhere? What do you understand by the anywhere? Anywhere means here in this term, in the linear space, in the real time, in a linear real time space, and the space is given in the this R. So यहाँ तक समझ में आया बेटा? Please let me confirm. थोड़ा बहुत समझ में आया?
Yes, sir.
Okay.
Yes.
Okay. So now Another definition is also given, that is also formal. You can say a system is bookish language. In the bookish language, this is given. A system is said to be controllable, if any initial state x of t naught or x naught can be, तो आप बताओ क्या लिखेंगे, can be please shifted or
Complete.
transferred
Transfer.
to any please final state.
Other states.
Final state, let's say x of t here in finite
Finite
time,
time.
in finite time interval, and let's say the interval क्या बन जाएगा बेटा, t naught minus tf
T.
minus t naught, tf minus t naught, okay, where t is greater than equal to 0, by means of, yes, by means of some, ऐसे चला जाएगा, ऐसे ट्रांसफर कर देंगे, ट्रांसफर करने के क्या चाहिए,
Unconstrained UT.
कंट्रोल इनपुट,
Constant input.
control input u by means of some control input u. Is it clear? Now tell me, अब आप मुझे बताएंगे प्रॉब्लम देख के सर क्या ये कंट्रोलेबल है या नहीं है, आप मुझे बताइए. Let's say we have a one problem, example x1 dot x2 dot, without test, with the help of the concept you can tell me, sir, either it is the controllable or not. So x1 x2 and 0 1 u. So please confirm, please tell me, the system is controllable or uncontrollable. ये सिस्टम कंट्रोलेबल है या नहीं, पहले बताओ. नॉट कंट्रोल. अब कैसे बताओगे, यस और नो, दिस प्रॉब्लम इज दिस और ना.
Yes, sir.
Okay. x1 dot is equals to what, x1 plus 2x2 plus 0u. अरे yes or no?
Yes, sir.
Okay. x2 dot is equals to, बोलो भाई.
X2.
2x2 plus u.
Huh?
1 plus 2x2 plus u.
Sorry,
2x2 plus
0 x1 plus 2x2
plus u.
plus u.
Plus u.
प्लीज टेल मी, ये जो x1 डॉट है, ये x1 और x2 स्टेट को, सॉरी